When we're given information for a quadratic formula or a quadratic problem, we want to figure out if we're going to use standard form, vertex form, or factored form to write the equation. So the examples I'm going to go through today are what happens if you are given a vertex and a point. And as the name says, we're probably going to be using vertex, all right, vertex form here. So in the little box, I have listed out the vertex form. Now you can either put it as f of x is equal to or y is equal to, but the vertex form is a times x minus h squared plus k. And I want to make a couple of notes specific to that format. Okay, so my first note is that the vertex point itself is the point hk. So if you know the vertex, you now know the value for h and you know the value for k. And the other thing that I'm going to mention is that any point on the parabola can be represented by xy. Those are your ordered pairs. So using this point as hk and any other point on the parabola or the quadratic, you can fill in x and y. So this equation that has 5 different pieces of information in it really comes down to only having the a value as unknown. So that's what we're going to practice in this video is if I have a vertex and a point, how do I find a? All right, so in problem number 1 here, this first example, it says write a quadratic function, okay, where the vertex is 1 comma negative 4. So if that's my vertex, that means that this is my hk. All right, and the function goes through the point 2, 5 here. So 2, 5 is going to be my xy. So I'm actually going to write that off to the side just so I have some space. Let's see what we've got here. 1, negative 4 is hk, and 2, 5 is xy. So now what I'm going to do is use what I know of the vertex form. So vertex form is y equals a times x minus h squared plus k. Okay, and I'm going to zoom in on that because this is really now this function and this information are all I need. So I'm going to go through letter by letter, variable by variable. Y is going to get replaced with 5. All right, so 5 equals a I don't know. That's my whole point of figuring it out. X is going to get replaced with 2 minus h gets replaced with 1 squared, and then it says plus k, but k is a negative 4, so you could either put plus negative 4, or if you just want to write it as minus 4, that's the same thing. So I've replaced everything in that vertex form equation except I don't know what a is. Now my job is to figure out a. So I'm going to add 4 to both sides. So 9 is equal to a times 2 minus 1 squared. Inside the parentheses, I'm going to do 2 minus 1 is 1. 1 squared is, well, that's going to turn into a times 1, which means a is just 9. So now it says, back at the beginning of this problem, it said write a quadratic function. So I'm going to use function notation for this instead of using the variable y. So function notation f of x is equal to, now I know what a equals, so I'm going to go ahead and use that a value. So 9 times x minus, my h value is 1 squared, and then minus 4. So we replace the specific a value for the problem and the vertex values, but leave x and f of x, or x and y, to represent the fact that this parabola can be any point, right? It's the whole curve. It's not just one specific point on the parabola. All right, we're going to do it one more time. So let's see, we've got write a quadratic function where the vertex is 3, negative 2. So let's see here. We're going to have 3, negative 2 as my hk. And I know that it goes through the point 0, 16. So there's nothing special about 0, 16 other than we know that it's a point on the parabola, so we're going to call it xy. Okay. Vertex form, since we have a vertex, we want to use vertex form. And let's see, vertex form is y equals a times x minus h squared plus k. I'm going to zoom in because, again, this equation and these 2 points are all I now need. Y gets replaced with 16. A I don't know. X is 0 minus 3 squared plus a negative 2 is the same thing as just minus 2. So I'm going to add 2 to both sides. So 18 is equal to a times, let's see, 0 minus 3 is negative 3. Negative 3 squared, be careful with your sign. That's just going to turn into 9. Divide both sides by 9. And I get a is equal to 2. So if I go back to the directions here, it said write a quadratic function. So knowing a is great, but that's not the whole answer. You need to take it to the point of actually writing out the function. So the function here, f of x is equal to, I know my a value, times x minus h is 3, squared, either plus negative 2 or minus 2. It won't matter which. All right. So again, we replaced the a value with what we figured out. We replaced the h and k from the vertex, but leave x and f of x to represent every possible point on the quadratic, not just the one specific point that was given to us. All right, I hope this has helped clarify some issues and concerns with using vertex form to write a quadratic equation when you have a vertex and a point.